A luminous, interstellar object is approaching the solar system. Could it be the Trisolaran's droplet? There's new a discovery about Atlas, and it brings a new mystery. It's too bright. Unnaturally bright, leading to suspicions that it's emitting its own light. To investigate this extraterrestrial visitor, even with the Hubble telescope, distance remains one of the biggest challenges. It's simply too far away. Currently, we only have a vague concept of this object's appearance, because the resolution we have is only a few arcseconds for both its surrounding halo and its core. With so little information, it's difficult to accurately determine what it is, even though astronomers seem 100% convinced it's a comet. Anyone with a different opinion is practically a conspiracy theorist. That said, the brightness of Atlas is truly strange. As of now, the latest observed magnitude of Atlas is 16.4, at a distance of about 400 million kilometers from Earth. This brightness isn't exceptionally high. There are certainly brighter comets, but those are giant comets. For a relatively small comet, the kind of interstellar object we expect to encounter, this brightness is abnormal. It's unusually bright. Astronomers have been trying hard to explain why, and this has led to a bolder hypothesis. Atlas might be emitting its own light, artificial light. And the fact that this is supported by data makes Atlas a focus of attention once again. Most astronomers think Avi Loeb's ideas are ridiculous because he proposes unconventional, even sci-fi-like possibilities to explain the object's peculiarities. Regarding Atlas's brightness, it's easy to compare. At the same distance, it's at least 200 times brighter than the 2019 interstellar comet Borisov. In fact, when Borisov was that far away, we didn't even know it existed because it was so dim. Avi Loeb doesn't think it's a behemoth, while astronomers insist it's a smaller object that has just produced a lot of dust. But the word dust has become a cure-all for astronomers to explain everything in the universe we don't understand. Whether it's alien megastructures or other strange phenomena we see in the cosmos, dust is their favorite explanation. However, how could an object like Atlas produce so much dust without any detectable gas eruption? So far, spectral analysis of the object shows no signs of gas whatsoever. You can't have a massive, explosive eruption of dust without a significant amount of gas mixed in, yet we've seen no evidence of that. The only way an object could produce so much dust without outgassing is if it's incredibly large. Some even suggest its diameter is about 20 kilometers, which again makes it an unusual object, something that large shouldn't be entering our solar system frequently. Experts once predicted we'd encounter one about every 50,000 years, so either we're incredibly lucky or this explanation doesn't hold up. So if it's neither a bright cloud of dust nor a massive object, what could possibly produce such a strong light? This is where the artificial light hypothesis comes in. Atlas might be self-luminous. For an object of this size, the artificial hypothesis is a bold explanation. Let's look at Avi Loeb's perspective and see what he thinks of the latest data. First, the analysis of Atlas's halo brightness distribution. Scientists found a key piece of data, the light curve slope, which, in plain terms, means the brightness drops off exceptionally steeply from the center to the edge. The steepness far exceeds that of any known natural comet. This means Atlas's brightness fades much faster than expected. You see, the light from a normal comet is diffuse, like a uniform, scattered cloud. But Atlas's light is like a very bright central flashlight, with the light dimming sharply from the center outwards. This pattern strongly suggests a lighthouse-like bulb at its center, rather than it reflecting distant sunlight. To be precise, it's a predicted -3 power law slope, which implies a three-dimensional emissivity distribution with a projected power law slope of -4. If Atlas is indeed self-luminous, its size might be much smaller than what is inferred from the reflected sunlight model. The reflection model requires a diameter of up to 20 kilometers, which is untenable because the limited reservoir of rocky material in interstellar space could only send a rock this large our way about once every 10,000 years. Considering how unusual this encounter is, plus the fact that this object is right on the ecliptic plane, approaching the solar system and passing close to 3 different planets on the same trip, connecting all these observations makes the possibility of it being a natural object extremely low. But Avi Loeb did some calculations to determine how much luminosity Atlas would need to produce to match our observed brightness. First, he calculated that Atlas's luminosity would need to be in the tens of megawatts range, equivalent to the energy produced by about 10 nuclear reactors, a huge amount of energy. Second, he realized that the steep brightness distribution around Atlas means its core dominates the light we observe. This again confirms that the core itself is emitting light. Whatever the source of the light, this must be true. In other words, the core's light outshines the light from the surrounding halo. Sunlight cannot explain such a steep, scattered light distribution. In a reflection model, sunlight would be the primary light source because the area of its rocky core capable of reflecting light is very small, far smaller than the 10,000 kilometers region resolvable in the Hubble Space Telescope images. Therefore, it could only reflect a tiny fraction of the sunlight's intensity. Another possibility for this steep brightness distribution is that the scattered halo is composed of ice particles. As they move from Atlas's warm sun-facing side towards the sun, these ice particles evaporate. This could explain why these scattered particles don't form a tail. But it's currently unclear if this would lead to the observed brightness distribution. And even if this is a natural phenomenon, it's very different from any comet we know. This reminds me of a classic quote, "Smallness and ignorance are not obstacles to survival, but arrogance is." Cosmic mysteries that challenge our understanding like this are perfect to ponder before bed. If you don't want your phone screen to disturb your sleep, you can try the Soda Music app in the bottom left. Its Listen on Douyin mode allows for screen-off playback and a sleep timer, so you can peacefully listen to these secrets of the universe. But before you sleep, let's first see what conclusion we get if we use the simplest tool, Occam's razor. The core of Atlas itself is producing most of the light. It's calculated that this core cannot be a thermal radiator with a temperature below 1000 Kelvin. Otherwise, its peak emission wavelength would exceed 3 microns and show an exponential cutoff at shorter wavelengths, which contradicts the data. At a higher effective temperature, the required luminosity of Atlas could be produced by a source less than 100 meters in diameter. A compact, bright light source would make Atlas's size comparable to Oumuamua or Borisov, which is much more reasonable than the 20-kilometer size inferred from the reflected sunlight model. But what could this light source be? First, Avi Loeb calculated that a primordial black hole with a Hawking temperature of 1000 Kelvin could only produce 20 nanowatts of power, which is clearly insufficient to drive this light source. A natural nuclear source could be a rare fragment of a nearby supernova core rich in radioactive material. But this possibility is extremely small, as the reserve of radioactive elements in interstellar space is very scarce. Another possibility is that Atlas is a nuclear-powered spacecraft, and the dust ejected from its front surface is accumulated grime from its interstellar journey. Dr. Avi Loeb also explored another possibility, that the object is traveling through this dust cloud, through all the extra dust that seems to exist in a ring around the object, at such a high velocity that friction is creating the light. But this possibility seems to have been ruled out. We can't imagine an interstellar environment with enough dust to create that much friction. So the explanation of it being an artificial object emerges, because it's hard to imagine such a small natural object could produce such strong light on its own. The orbit of this self-luminous object happens to be on the ecliptic plane, approaching our solar system. It happens to pass within 1 astronomical unit of Mars, Venus, and Jupiter. In fact, the object passes Mars and Jupiter at a distance much less than 1 astronomical unit. So close that if Atlas were a mothership, it could easily dispatch interstellar probes to these 3 destinations, perhaps using tools as simple as artificial intercontinental ballistic missiles. Finally, of course, at its closest approach, the object is exactly on the other side of the Sun, opposite the Earth, which makes human observation of this object much more difficult. This might also be intentional. These are Avi Loeb's views on Atlas. Currently, his speculations have some data to support them. But if this object is artificial, what could it be? What about its surrounding halo, that cloud of dust? Avi has talked about one possibility, that it might be material sprayed in front of the object to detect any potential dangers. Any tiny object colliding with Atlas at this speed would be devastating. However, there is currently no real hard evidence to prove his hypothesis. But as Atlas continues its journey through the solar system, it will get closer, and astronomers will learn more about it. In any case, even if it is natural, it is a natural object older than our solar system. Who knows what strange phenomena it has encountered on its journey? Maybe it had some kind of close encounter with a black hole that ejected it. Who knows what happened to this object during its travels? Turning the unknown into the known, and then the known brings new unknowns. Perhaps this is the charm of scientific exploration. What do you think about this? Is it a natural wonder or a relic of civilization? Let's talk about it in the comments.